we have got. So now one problem we will see with respect to the voltage divided by S. The parameters are given. VCC is 16, RC is 3 kilo ohm, RE is 2 kilo ohm, R1 is 56K, R2 is 20K, and alpha is 0.985. So this is the values of the different parameters given. They are asking us to find the operating point and the stability factor. Yes. Soon as you see the voltage divided by S, you have to find RTH and VTH. And it is given germanium transistor. So the VB value is fixed as zero point 0.3 and alpha is given. From alpha find out beta. So alpha is 0.985. So from that find beta. Beta is 66. So immediately you have to see in the question whether it is silicon or germanium. Silicon means you know it is 0.7. Since it is specifically given a germanium transistor, you have to use 0.3 volt only. And you know the expression for VThevenin. VThevenin is R2 into VCC by R1 plus R2. So it is 4.21 volt you get. And RB is going to be R1 R2 by R1 plus R2. You get 14.737 kilo ohms. So these two formulas directly you can write from Thevenin's theorem, voltage and Thevenin's resistance. And initially the value of VB and beta you have to find from the whatever is given in the question. Okay. Now we apply the basic KVL equation what you have, and you find out the collector current. So wherever you have the base current replaced by IC by beta, you can get the collector current as 1.73 milliamperes. And since the base current is very small, you can assume the emitter current also to be 1.73 milliamperes. And now VC applying KVL at the collector side, you get the expression like this: VCC equal to VCE plus ICRC plus IERE. From that, you can rearrange and find what is VCE. VCE is 7.35 volt. Actually, the operating point means you have to write the value of VCE and IC. Q point means you have to know the values of VCE and IC. So whatever KVL equations you have to rearrange them and get the value of VCE and IC. See, VCE is 7.35 volt. The design is 16. 16 by 2 is 8. So ideally you should get 8, but practically it is close to 8, 7.35 volt. And the collector current is 1.73 milliamperes. So all these two values for VCE and IC are available. The value of VC and IC are the operating point of your transistor. VCE and IC are the operating points of the transistor. Stability factor formula is given. So write the stability factor. S is equal to 1 plus beta into 1 plus RB by RE by 1 plus beta plus RB by RE. So stability factor you see it is 7.537. It is very much less. Stability factor is very much less when you compare to the other biasing circuits, whatever we have studied so far. So this is very, very simple. Once you know the formulas, you can easily uh, get the expression for voltage and current, and you can find the operating point.